Hello and welcome. In this session, we will navigate the critical decision-making process between NVIDIA InfiniBand and Ethernet technologies for building high-performance AI data centers. Let's start by understanding why the network is the foundation of the modern AI data center. It's not just about connecting wires anymore. The network literally defines the data center's performance capability. You generally have two paths: NVIDIA Quantum InfiniBand, which is the de facto standard for massive scale-up systems like supercomputers, and NVIDIA Spectrum-X, which revolutionizes Ethernet for the AI cloud. Traditional networking concepts often fail here because AI generates massive bursty data flows called elephant flows that can cause congestion in standard networks. Today we will learn how to choose the right path for your specific needs. This flowchart visualizes the high-level decision path we will explore. Starting at the top with the AI data center, we split immediately based on the primary use case. If you're building an AI factory for dedicated massive-scale training, the path leads to InfiniBand for maximum performance. If you're building an AI cloud requiring multi-tenancy and broad compatibility, the path leads to Spectrum-X Ethernet. We will break down these branches in detail throughout the training. To select the right technology, you must identify your facility type. Are you building an AI factory? These are specialized facilities designed for one thing: training massive foundational models like LLMs across thousands of GPUs. Here, every microsecond of latency matters. On the other hand, an AI cloud extends traditional cloud infrastructure to support generative AI. In an AI cloud, you might have thousands of different users running different jobs. Here, performance isolation is key. You cannot let one user's heavy traffic crush another user's performance. On the left, we see the AI factory model: dedicated resources tightly coupled for massive training tasks. This is where InfiniBand shines. On the right is the AI cloud model: shared resources handling diverse generative AI applications where isolation and flexibility are paramount, making Spectrum-X the ideal choice. Understanding this distinction is the first step in your technology selection. Now let's examine NVIDIA Quantum InfiniBand. This is the gold standard for high-performance computing. Its defining feature is that it is a lossless network. It uses a credit-based system to ensure packets are never dropped due to buffer overflows. But it goes further with in-network computing. Using a feature called SHARP, Scalable Hierarchical Aggregation and Reduction Protocol, the switches themselves perform data calculations as data moves through the network, doubling the effective bandwidth for collective operations. It also features self-healing capabilities to instantly route around failures. This diagram illustrates the power of in-network computing. Instead of just passing data between GPU nodes, the quantum switch actively participates in the calculation using SHARP. Data flows up to the switch, gets aggregated and reduced there, and sent back. This offloads work from the GPU and drastically reduces traffic. Additionally, note the self-healing path. If a link fails, the switch hardware handles it instantly without software delays. Moving to NVIDIA Spectrum-X, this platform enables Ethernet to perform like a supercomputer network. It combines the Spectrum-4 switch with the BlueField-3 Super NIC to overcome traditional Ethernet limitations. Standard Ethernet creates noisy neighbor problems where one workload slows down others. Spectrum-X solves this with performance isolation and ROSI (RDMA) over converged Ethernet extensions. It enables adaptive routing on a per-packet basis, ensuring high bandwidth utilization without the packet loss or latency spikes typical of commodity Ethernet. This diagram shows the Spectrum-X synergy. The BlueField-3 Super NIC sends ROSI traffic to the Spectrum-4 switch. The switch applies adaptive routing to spray packets across all available paths while simultaneously using telemetry for congestion control. Together, these features drive performance isolation, resulting in up to 95% effective bandwidth utilization, far higher than traditional Ethernet's capacity. Under the hood, both technologies rely on RDMA. RDMA allows data to move directly from the memory of one GPU to another across the network, completely bypassing the CPU. This is critical for AI. InfiniBand does this natively. Ethernet uses a protocol called ROSI to achieve the same result. While traditional Ethernet struggles with ROSI due to packet loss, Spectrum-X uses lossless techniques to make ROSI rock solid, enabling the high-speed GPU-to-GPU communication required for training large models. This sequence diagram illustrates the efficiency of RDMA. Notice how the data flows from GPU A to NIC A, across the network to NIC B, and directly into GPU B's memory. Crucially, the system CPU is not involved in the data path. This direct line is what allows both InfiniBand and Spectrum-X Ethernet to achieve the ultra-low latency required for AI training. Let's compare the unique performance boosters. InfiniBand uses SHARP to perform math in the switches, reducing the data sent over the network, literally reducing the workload. Spectrum-X focuses on adaptive routing. Traditional Ethernet picks one path for a flow, ECMP, which causes collisions. Spectrum-X sprays packets across all paths to fill the pipes evenly. The BlueField-3 Super NIC then puts these packets back in order at the destination, giving you the best of both worlds: Ethernet compatibility with near InfiniBand performance efficiency. Here we visualize the difference in routing. On the top, traditional Ethernet forces a flow down a single path, often leading to congestion if two elephant flows collide. On the bottom, Spectrum-X sprays packets across multiple paths, avoiding hotspots. The BlueField-3 Super NIC at the end handles the complex task of reordering these packets so the application sees a clean stream. So, how do you choose? Select NVIDIA Quantum InfiniBand if you're building a dedicated AI factory where raw training speed and scale are the only metrics that matter. It remains the king of throughput and latency. However, select NVIDIA Spectrum-X Ethernet if you are building an AI cloud that must support many different tenants or integrate with standard Ethernet management tools. Spectrum-X offers the necessary performance for AI while fitting into the versatile world of Ethernet operations. This decision tree guides your final choice. Start with your primary goal. If it is pure, uncompromised AI performance at massive scale, the path leads to InfiniBand for an AI factory. If your goal balances AI performance with multi-tenancy, standard operations, and diverse workload support, the path leads to Spectrum-X for an AI cloud. Use this logic to align technology with business needs. To summarize, NVIDIA offers two optimized paths for AI networking. InfiniBand is the mature, ultra-performance choice for dedicated supercomputing clusters. Spectrum-X is the modern, accelerated choice for cloud-scale multi-tenant environments. Both rely on RDMA to bypass CPUs and unleash GPU power. By understanding the distinction between an AI factory and an AI cloud, you can confidently select the right architecture. What did we learn? We learned that while the protocols differ, the goal is the same, keeping GPUs fed with data. We conclude with this lifecycle view. Your analysis of the workload dedicated versus multi-tenant drives the platform choice. Whether you choose InfiniBand for the factory or Spectrum-X for the cloud, both paths lead to success by utilizing NVIDIA's full-stack optimization. Thank you for watching.